carpool this morning? Stand by. Nothing is stopping you from typing two names and doing anything.
Well, that was my idea.
Hey. Who else is absent today other than Evie? Ethan, you also, right? What do you know anyone else absent other than you? Ethan, you and okay. Yeah, we'll start. You want to music? Ready you all to refresh yourselves up. Okay, this is very basic content. Ionic bonds formed between metals and non-metals. Hope you know where your periodic table you can find this information. Where the metals are, where the non-metals are. You cannot possibly choosing metals and metals are. You cannot react. Non-metals and non-metals is the bond we learned yesterday, covalent bonding. Okay, so I did expect a full marks from this, but we didn't. Next one. When chlorine becomes an ion, what is the charge? How do you solve it? How to do this? Chlorine is in group 17. That means it has 1, 2, 3, 4, 5, 6, 7 valence electrons. That means it only needs one more to become full, to become an ion. Okay, so check the group to figure out what the charge will be. There'll be more of such questions coming up. Magnesium, not magnesium. Okay, well done. Most of us got this. I chose calcium because for some reason, when you think of calcium, you think of milk. Then you're like, oh, okay, it's not metal. No, calcium is not milk. Okay, calcium is a metal.
So our bones are made out of metal?
No. So when people say your bones have calcium or there's calcium in milk, they're referring to the compounds of calcium. So in milk, there are compounds that are made of calcium plus another non-metal. So you're not taking the metal. Sorry, calcium and the non-metal. So you're taking compounds of calcium. We do not eat metal calcium. Well done. Knows this 1%. Not bad. 287, therefore I use 70. Non-metals like oxygen, chlorine, what kind of ions will they form? There are two answers. Okay, either negative ions or anions, both are the same thing. What you should not have chosen are cations. Okay? Ayo, a lot of you all chose cations. So, be very clear, all the metals on the left hand side form cations. They like to lose electrons. Lose negatives in your life, become positive. Those small sections up here are the non-metals. They tend to gain, become negative. So I spell it wrongly as magnesium, not magnesium. You know that? Very good. Magnesium is in group 2. So 2 valence. You want to lose the 2 valence electrons. Okay? We do not write that as a plus 2. We write that as 2 plus. I tell you why you don't write that as a plus 2 or minus 2. You do that in math. When you write the plus or the minus first, it's like telling the person you need to subtract or to add. But we're not subtracting or adding anything. We use the plus and minus as an electrical charge. Okay, so we put it as the second part. Three. Actually, Brian is right, it's 2. Nearly there. I look forward to the question when everyone gets correct. strong. Okay. So please be very clear. Group 1, 2, and 3. Very likely they'll form paired ions. Okay, and we just did a very similar question. So to those who got it wrong, please learn. Okay, let's learn from mistakes. Metals from paired ions. I'm going to write this on the whiteboard. Prove to you that you're not learning from your mistakes. Metals form paired ions, which are positive in nature. Non-metals and ions. So for example, sodium, magnesium, aluminium. For example, nitrogen, oxygen, fluorine. Periodic table, you will see the answer. So if you got wrong, just untang one, right? How whack? Calcium. Then how are you playing? You. Because it's one full. So you are recording so that the other can play. Then you are not playing. What's the charge of the oxygen ion? Those who got it wrong, please pay attention. Oxygen is in group 16. So it has 1, 2, 3, 4, 5, 6 electrons. It just needs 2 more to be full. If it gains 2 more, there will be a 2 minus. Okay? Okay, so try this same thing out. Aluminium. Which group is aluminium in? Oh, actually, I'm wrong. I should have it. Okay, 3 plus, because you lose 3 electrons. Show you, even if this on a whiteboard, you will not get it. These 3 of you okay, look up, pay attention. Please, yeah, you have 50% chance at that. Two more questions? Good job, Vera. right. Third place, we have now. Who is this?
Your grandmother.
Who is French Ghost?
Olivia.
Olivia?
Olivia.
Oh, why are you French? Are you French?
Yes.
You are French?
Yeah. We forget. Are you French? No. It's an inside joke.
Sorry, you have French lineage in you.
Yeah.
Wow. Okay. Yeah, Olivia, I will give you baguette. Okay. And Shu Hao is Shu Hao. Okay. Who is Eve side and who's Eve side and? Oh, okay. Well done, well done. Okay. This morning. Okay. So this is how far we've come. We ended off with two questions. One question on the structure. Yeah. So we've learned a few kinds of bonds so far. You should have a textbook with you. The usual culprits, they don't flip the correct page of the textbook. Now's a good time to open your textbook. Perhaps take it out of your bag and flip to page 58. The person that starts with a K. Second part, why? Okay, this is how far we've come. We have learned that there are elements and compounds. So there are metal elements as well as non-metal elements. Metal elements tend to want to lose electrons. Non-metals tend to want to gain electrons. If you were to try to combine two metals and non-metal elements together, you end up getting ionic bonds that form ionic compounds. If you were to have non-metal and non-metal together, the bond that you'll be forming are covalent bonds. However, just take note, slight difference. If the non-metal and non-metal that is bonding together are the same, so if it's same element, for example, let's say oxygen or hydrogen or nitrogen, same elements combined, then we will, even though there's covalent bonds, this is still an element. However, if different elements, if different non-metals combine, for example, H2O, CO2, then we refer to it as a covalent compound. Okay, so this is why we have left off. We left off at ionic compounds, and yesterday we went down the route of covalent compounds as well as covalent bonds. Okay, following. Every lesson I try to draw a mind map. This is how I learn, so that I can draw connections between whatever we've done so far. Okay, so perhaps for yourself, how do you make notes? Do you draw connections between all the chapters? Or study page by page and memorize them? Okay, every lesson I draw the mind map slightly differently. I link it slightly differently. By the end of the day, you can do your own super mind map. I've seen a student, I was quite blown away and very touched. There's a JH4 senior that managed to do a super mind map of JH3 to JH4 topics of biology. She used digital platform. You know, some of your digital platform is endless space, right? But if you do on a piece of paper, it's limited space. So you can even use your digital platform because she did an endless mind map. When she zoomed out and out and out, you can see a big mind map that links every concept together. And when I ask her one thing, she can just trace through her mind, through all the links to find that information. She doesn't really memorize now because she understands the links. Okay, so this is where we are so far. Today's scope of the lesson is we are going to learn about some of the properties of ionic compounds as well as covalently bonded substances. So what are the properties? This is what we're going to look at. And we will have a conclude today after we learn this. Yeah, so we'll play 2 times today. Okay? So we are going to learn about the just shake his head when you hear conclude. Okay, so the ones in purple are what we're going to learn today. We're going to learn about the physical properties. So what are the physical properties of substances bonded by covalent, bonded by ionic? Okay. Later on, I will start to expand on this mind map. Maybe I'll expand it up here. If you want, you can add to your mind map later on. So I will branch out 2 ways. Here, today we're going to learn about what the physical properties are. Okay, then we'll play a Kahoot to test all the physical properties of these kinds of bonded substances. What do I mean by physical properties? I mean to say, is it hard? Is it soft? Can it melt at high temperatures or low temperatures? This is what physical properties mean. What page am I on today? May I get you to go to page 58? Everyone go to page 58 of your textbook. May I get you now to highlight all of the headers for the physical properties of ionic compounds. What do I mean by that? For example, you see how many bullet points? You see 4 bullet points. It says high melting and boiling points. Highlight that. Header number 2. Good electrical conductors when molten, and so on and so forth. Highlight that. Number 3, soluble in water. Highlight that. Number 4, hard and brittle. Highlight that. These are the 4 properties we're going to learn today of ionic compounds. Very good. Properties mean. The aim of today's lesson, we're going to cover that and make clear, and I hope you, other than that, understand why they have these properties. Okay, as we go through lessons, your textbook, the more blank it is, the less you will have to take away for your revision. So, as a good learner, when you listen in lessons, read your text as we go. Yeah? Usually what I say is an elaboration of what's already in your textbook. So as I describe, as I teach, look at your textbook, also read what's there. If what I say is the same as what your textbook at certain points, go and highlight those words. That means it's very important. Okay? So that's what good learners do. If you want to look at some of your friends who are, that you admire, find quite good in their studying methods, I bet you are very often you look at their textbook, it's filled with scribbles, may not be very neat, but it's filled with a lot of learning points. Usually can tell who will have a very, very good time during the exam based even on your textbook, how blank or how thorough it is in your revision. So for example, when I look at some people's textbook, it worries me. Yeah. Come here with a lot of reminders. Every time I spoke to you, then you will start writing. Okay, so let's look through the 4 properties of ionic bonded substances today.
Many ionic compounds do not just exist in a laboratory or in your chemistry homework. Sodium chloride is regular table salt. Sodium fluoride is added to some toothpastes to help strengthen tooth enamel. Ammonium nitrate can be used to fertilize plants. Although their real-life applications are very different, they share a few key properties. In this lesson, we will learn about the properties of ionic compounds. These ionic compounds have very high melting points and are brittle because of their 3D giant ionic lattice structure. The strong electrostatic attractions holding the 3D lattice structure in place mean that a lot of energy is required to overcome these attractions. When we apply force, it breaks the regular repeating pattern of oppositely charged ions, causing ions with like charges to come close to one another. The ensuing repulsion breaks the lattice structure. Sodium chloride, sodium fluoride, and ammonium nitrate can all dissolve in water, as we know. Or else, we wouldn't be able to flavor our soups, brush our teeth, or fertilize our plants. Most ionic compounds are soluble in water. In water, an ionic compound can dissociate into its ions. So when we dissolve sodium chloride, it will dissociate into sodium and chloride ions. These ions become stabilized in water due to the polar nature of water.
I shall skip this part. This is what your JH3 seniors learn.
Water can conduct electricity, and ionization stabilizes the free-floating ions. An ionic compound dissolved in water can conduct electricity. This is another key property of ionic compounds. This is made possible due to the presence of free-floating ions. We can dissolve copper 2 sulfate in water in a beaker. Add a few drops of sulfuric acid. Place a strip of copper and a strip of zinc into the solution. These will act as electrodes. Using 2 alligator clips, connect one strip to one end of the mini light bulb and another strip to the other end to complete the circuit. You will see that the light bulb lights up. Hence, the solution conducts electricity. Following on the same idea, molten ionic compounds can also conduct electricity.
Molten means melted. Ionic compounds that we melt can conduct electricity as
The
well.
lattice structure is broken at high temperatures, and so the ions become free-floating. In summary, ionic compounds have high melting points, are brittle, and can conduct electricity when dissolved in water or molten due to the presence of free-floating ions.
Okay, so those are the properties of ionic compounds. If you look into your textbook, there are quite a number of points that we can take note of. So as I run through the points, have your highlighter with you, or maybe a pen as well, to take note of the key points. Usually, if you notice by now, your textbook, the important points are always bolded. Yeah? We always bold important vocabulary. Make it easier for yourself to see by highlighting those bolded words as well. What are you looking at? Oh, you're looking at this comic strip. What is it saying? I have an extra one. Here you can take it. I only have 17 electrons. I feel so much better, but I thought more. Oh, yes, I'm positive. Yeah. So what kind of relationships do you aspire in life? Do you want a give and take relationship? Or do you want a sharing relationship? What? Wife have no sperm.
Wife and husband.
What? Oh, wife and husband. Sorry. I was like, what are you talking about? Crazy friend. Okay. So there are 4 physical properties we expect you to know of ionic compounds. We also expect you to know why they behave this way. So first and foremost, first kind of property you can look at is melting and boiling points. Okay, whether they can conduct electricity, whether they can dissolve in water. Okay, and these are the kinds of properties that we want you to look at. Other than the physical state at room temperature, do they tend to be solid, hard, or is it liquid, or is it gas? Okay, so usually these 4 roads that we will lead down. Yes. Okay, I think Ethan asked a very good point. Because we just learned that ionic compounds have high melting point, boiling point. It is hard, so on and so forth. And then Ethan then goes on to ask, therefore, is glass made out of ionic compounds? That's a good question. I like why he's asking this. He now knows the physical properties. Now you can always ask yourself, if this is a physical property, does that mean it could be ionic compound? This is hard also, right? Does it mean it's an ionic compound? So these are important questions to ask. Okay, my reply to you is that no, it's not ionic compound. However, there are other kinds of compounds that also have similar properties, which we will see in a while. So, what are some examples of ionic compounds that you have in your daily life? For example, have you seen a block of salt before? Yeah? A block of salt, number 1, it is hard. Okay, if you look at your textbook, there are 1, 2, 3, 4. Okay? We look at point number 4. It is hard and brittle. Is salt hard and brittle? Yeah, actually salt is hard, but at the same time, if you were to press down, you notice it can sort of crumble. Yeah, that's what brittle means. It can crumble. But why does it crumble? This is the diagram I'd like you to pay attention to. In your textbook on page 59, it shows why salt crumbles easily. Because even though it is indeed hard, the moment you apply some pressure on a part of it, you end up forcing some of the ions to end up repelling each other. Okay, so you look at your textbook, I'd like you to draw a little bit of additional diagram onto the diagram. Yes?
What is sugar made of?
Oh, okay, that's a question. Okay, Jack, I need to write this down so I can answer you. Because isn't sugar behaving kind of like salt, right? When we press down. Okay, so let's answer that in a while. So if you look at your diagram in your textbook, the diagram goes something like that. You draw a plus, a minus, a plus, and that section has been shifted down. Right? You observe that this section has been shifted down. Yeah? Use a different colored pen. What you could do is you can go and show repulsion. Draw arrows that are facing away from each other. Okay? This is why they crumble very easily. When you give a slight press, if the ions that are similar in charge, just nice align with each other, they will repel. And it starts to break apart. Jet asks, is sugar therefore ionic compound? Because it also behaves this way, it's also hard and brittle. Yeah? That's a good question. Sugar, although hard and brittle, it is not an ionic compound. Okay, it is not. So, I would like you also to realize that if you want to consider whether something is an ionic compound, it has got to hit these 4 points. Okay? Think of it as a checklist. So if, for example, I were to give you an unknown compound, and I tell you the physical properties, and it hits all these 4 points, then yes, it's an ionic compound. Could other compounds have similar properties? It could have similar ones, but if it doesn't hit all 4, then we wouldn't consider it an ionic compound. Okay? So that's why we have this checklist. So that's the first point we take note of. It is hard and brittle because it can repel if you were to give it a press. Can you see the words that I just said in your textbook? Yeah? So look at the paragraph below. Okay, I need to teach you how to read large paragraphs. Don't want you to, when you come to the exam time, you see lots of words and you get shocked. So if you look at the textbook, actually what the teacher has just said is also there. If you look at slightly below the last paragraph, it says repulsion between ions. So if you are very keen and you are a good reader, you realize that sometimes it's not about frantically copying what the teacher says, it's also about reading and matching up. If it matches up and it's important, I highlight it. Okay? Okay, today I'm explicitly teaching you how to make notes because unlike previous chapters where we do a lot of practice, this one is more heavy words. Okay, so that's the first physical property. Second, ionic compounds also have very, very high melting and boiling points. It takes a lot of temperature, very high temperature for it to melt. Have you ever melted salt before? You cannot melt salt, you know. Yeah? Salt requires you to go up temperatures of thousands of degrees for it to melt. Salt does not melt very easily by your own action. But why is that so? Because ionic bonds are actually very, very, very strong. The attractive force between a positive and negative charge ion is extremely strong. Okay, that is an ionic compound. What do we call such an attraction? I think for our class I did not introduce this word. Electrostatic. Okay, forces of attraction. Can you use your sharp eyes to find these words in your textbook and highlight it? Do you see electrostatic force of attraction? Okay, I saw it once in your textbook. Okay, on page 56. Look at page 56. Look at 11.2.1. Page 56, 11.2.1. You see ionic bonding is defined as electrostatic force of attraction. Highlight that. Mr. Kang Yo. Okay, so if someone were to say electrostatic force of attraction, they are simply saying the attraction between the plus and the minus. This attraction is really, really, really strong. We need very high temperatures to be able to break them. That explains why the melting and boiling point is very high. Okay, so that's the second property. High melting and boiling point. Next property, which you probably experienced before, dissolve salt before in water. Yeah? Salt kind of just disappears in water. That's because ionic compounds can dissolve. Where is my dissolver? Okay, ionic compounds can dissolve in water. In JH3, you will learn why they can dissolve in water. That's not our focus for today. But being able to dissolve in water helps with one thing. Let's write down it can dissolve in water first. So if you see the word soluble, soluble means can dissolve in water. The last most interesting point is that it can conduct electricity. But take note, it can only conduct electricity if it is dissolved or melted. But the proper way to write it is molten. Molten means melted. You know molten lava cake? You know when you eat the cake inside it's melted, come on. So that's what molten means melted. Ionic compounds can conduct electricity only in these two forms. Because when dissolved or when melted, all these ions are now free moving. They are now no longer bound by each other. They are free to move anywhere they want, and they can now carry electricity. Okay? If you look in your textbook, there are certain words I'd like you to highlight. You see over there, you see on the top of page 59, it says that ionic compounds are made of ions. They are held in fixed positions. Okay, ionic compounds are held in fixed positions. They are ions. However, when melted or dissolved, later on if you read the later paragraphs, they say mobile charge carriers. Can you highlight the word mobile charge carriers in the second paragraph of page 59? Second paragraph of page 59, highlight mobile charge carriers. This is an important word. When you see the word mobile charge carriers, second paragraph, mobile charge carriers. When you see the word mobile charge carriers, it means that mobile means can move. Charge means it can carry electricity. Carrier means can carry. Okay, so mobile charge carriers. When ionic compounds are melted or dissolved, they become mobile charge carriers. They can carry electricity. No, I did not write anything new, but I'm telling you all to do something. I see Charles also knows. Okay? So, I'd like you to use this particular vocabulary. Make sure you go and start the word mobile charge carriers. There's an explanation for why they can carry electricity. In a solid state, ionic compounds are not mobile. They cannot move. So they will not be able to carry electricity. One of the teachers conducted an experiment. And I think it worked. So what she did was, she took water, after which she placed salt inside. Okay. Let me search for video instead. Salt,
If you have an hour this week, you can learn 100 songs on the piano by learning just 4 chords. These.
Here we have a giant light bulb and it's going to be connected. Okay, here you see two metals and they're going to connect to, and the metals are going to be inserted into water to allow the salt to dissolve. The light bulb does not light up, but as we add salt in, then it starts to light up. Because as the salt goes in, all the ions are now free to move. They become mobile charge carriers. Some of you may be wondering, sure, I thought water can conduct electricity, right? They always say, make sure don't get water near the sockets, right? But then over here, how come the water just by itself doesn't conduct? Okay, because the reality is, the water you get from your taps, they have salts inside. Okay, so that's the reality. If you were to take water from a tap, just go and get water from the tap. Actually, the water from the tap is not pure. It has a lot of dissolved salts inside. That's how you can test. I mean, don't go and test. If you get conductor electricity means it's a bad thing. You do not need to find out. But actually, in our lab, we do have the purest of water. Have you ever seen those bottles in the lab where you get to squeeze and then you shoot out water? The water inside those are very pure. There's no salt or contaminants inside. If you try to light up, if you try to do the same experiment and put a light bulb there, it actually won't light up. Okay? But the reason why we ask you not to put electrical substances, appliances near water at home is because your water at home is not pure. Lots of dissolved salts inside. Even though it's not salty, okay, but it's very diluted salt inside your water. Are you asking, can you drink the water in the lab? Oh, okay. So you tell us, yeah, so actually in the lab, if you have that very pure water, then pure water actually won't conduct electricity. But I still would not advise you to go and conduct the experiment because you know, there's also salt in your sweat. Later you just one time sweat drop in and then you go and conduct electricity. Yeah, there's salt in a lot of places. It's just that the pure one we give you at the very start, it shouldn't conduct electricity. I just saw earlier on someone actually melted salt. Okay, melted salt also can conduct electricity. So God bless. This person did the experiment so that we do not have to. So here, there is salt inside. I believe this person is going to try to melt it in a while. Okay, so he's going to heat up the salt to extremely, extremely high temperatures. You actually cannot do this at home. You do not have enough heat to be able to melt salt. That's a special kind of glass. Wow, isn't it amazing when you melt salt? Actually, it looks very transparent also. Yeah. So melted salt, molten salt. Hey, as we are looking at the melted part, if we observe the side, look at the light bulb at the side. As it melts, as small ions begin to move, then it can start to conduct electricity. Look at the light bulb on the left hand side. It's starting to light up once it melts. Oh, okay, suddenly pop, and it's melted. Okay, as it lets it cool down, it should return back to its solid state. Notice that this is 3 times speed. So if you were to try this at home, you'll probably take extremely long to hit those temperatures. Okay? 4 properties of ionic compounds. Very high melting boiling points because of the strong electrostatic force of attraction in the ionic bond. Second, it can dissolve in water. And when dissolved in water, it can conduct electricity. Another way is to melt the salt. Then you can conduct electricity as well, but not in solid state. Last but not least, ionic compounds are also hard and brittle. It is hard, but it can break easily because in the right arrangement, same charges will repel. Next week, we are only have lessons with you on Wednesday. Yeah? Because Thursday, Friday, there will be no lessons. Friday is presidential election. Cannot say okay, so all of you are the public servant. That means I work with the government to ensure all of you have a good education. So I cannot be telling you all who to vote for. Cannot tell you lah. Somehow I'm being recorded. Then you all will do nonsense. Okay, I think since I only have 10 minutes left and I won't have time to go through the covalent, we like to just quickly test yourself with Kahoot. Okay, but the Kahoot has 1 or 2 questions relating to covalent properties. When it comes to that one, you make a wild guess. You make a wild guess. Only 10 questions. Yes. By right, you shouldn't. Yeah, by right, you shouldn't. Yes, how you go? In your what? In our food, is it? If there isn't K ions and N ions, there can be in our food. I mean, K ions and N ions form. Oh, okay, I understand. So if we cannot form opposite charges, then nothing can come together, is it? Okay, you're right. then actually we won't have so much variety of things. Yeah? If things cannot form opposite charges, then we won't be able to form new things. Yeah, you're right. We'll have less variety of things. Okay, some of the questions are pertaining to covalent properties. That one you make a wild guess lah, but the rest are ionic in nature. Okay, I'm going to begin. Okay, starting in 3, 2, 1. Okay, you have to guess this, huh? Okay, what blows my mind more is that when I never teach, you all get more correct and wrong. So something I must be doing something very, very off. The more I teach, the more confused you get. Okay, this one you also cannot do yet. But I'll be very impressed if you somehow can. I think you can infer. Okay? Because we learned the word mobile charge carriers, as long as that's present, it can conduct electricity. Okay, so it's a good guess for some of you here. Okay, now we go into what we learned. Which is not a property. Excellent. Yeah, it cannot conduct with solids. If it could, someone can go up, use sprinkle salt on you, then you're going to have a good time already. Another covalent one. This one you have to do some guessing. And this one will be very hard. I don't think you can get it. Okay, that's not correct or wrong. How come solid ionic compounds cannot conduct? Okay, I can see why you may have chosen this, but this is not a complete answer. If it is not free moving, then you cannot say it's mobile charge carrier. Only when it's free to move. In solid state, the ions are vibrating about fixed position. So it's a bit obvious. Oh wait, I don't think you can do this. Okay, this one is wild guess. Because they say which one can conduct in solid state? Why can dissolved and melted ionic compounds conduct electricity? Very good. Actually, there are two answers. Hey, so actually our whole class is correct. do ionic compounds have high melting boiling points? Oh, Shivani. Okay. Do you know that I just showed you one last video before you go up? A little disgusting, but just now when I say I throw salt on you, you're gonna have a good time, right? Okay, and then it brings to mind something. You know, the reason why you can move your hands and your body, your muscle, because there's a lot of electrical signals being sent by your brain. Yeah. So actually, I saw a video recently on putting salt on frog legs. Okay, these frog legs these legs are dead. Okay? Okay, dead they are dead already. But when you put salt onto it, watch what happens See what's happening to the legs? After salt has been added,
Why the head never go back yet? Why the head never go back yet?
but chop off your will it go back? Less, right?
Oh, that's pretty bad. Yeah, check this out. Oh, pretty good.
But why is this happening? Because on these frog legs, there's still a bit of water on it. Yeah, there's still a bit of water. So it's not solid salt that's causing this. It's when you sprinkle the salt on the frog leg, and when it dissolves into the water, into the blood, then electricity starts to conduct again, and you see the leg come alive, right? So yeah, just now when I told you I sprinkle salt on you, right, then I thought of the legs. Okay. Sometimes you feel your cramps in your legs, yeah, because sometimes they say your ionic balance is off. That's why sometimes your teacher may ask you to drink isotonic drinks. Inside isotonic drinks lots of flavor, because actually we dissolve a lot of salts inside. When you drink isotonic drinks, it helps to replenish the salts that you have lost inside your body. Then you won't feel all those cramps anymore in your muscles. Okay? What are you doing after that? Okay, so that's all for today. Next week we're going to learn about these branch of physical properties. Okay, then you will be able to do your output fairly. Okay, thank you. If you want to take photo, please go ahead.